Hey all, welcome back. I wanted to post a quick video to review the process of factoring. So to start out, what does it mean to factor? So factoring is really just the inverse operation to the distributive property. So even though distribution isn't like an operation, distribution normally deals with multiplication. So with factoring, we are doing division essentially. So I have these two expressions here that are actually equivalent to each other. And I'm going to show you how they're equivalent to each other through the distributive property and then through factoring. So this first expression here on the left says 6 times the quantity x plus 5. And since I have 6 times the quantity x plus 5, and I can't add my x plus 5 because they're non-like terms, to get rid of those parentheses, or to simplify this expression, I have to multiply the 6 by the x, and I have to multiply the 6 by the 5. So that gives me 6x plus, well actually I'll show all of my work. That's going to give me 6 times x, the plus in between them, and then 6 times 5. This gives me 6x, and 6 times 5 gives me 30. Now I can do the same process to factor that expression that we just ended with that I have over here. So when we factor, we're trying to say what is the GCF, or the greatest common factor from both of these values that I could factor out to actually make this kind of easier to think about. And it makes a lot of sense in situations relative to like cost or different things. Say I have 6 people coming to the party and each of them is going to cost me X dollars plus a fixed amount, $5. So we could say then maybe X is how many video games they're going to play, and that's the price of that, but maybe this $5 is for pizza and pop. So maybe I'm having a birthday party at Magic Mountain, and they say, okay, every person you bring is $5 for pizza and pop, plus whatever value of games they play. So then if I invite 6 people, I could figure out my price based off that. So I can do the inverse operation by factoring, so I can say between 6 and 30, because 6x and 30 are not like terms, so I just look at the numbers 6 and 30 and say, well, what could they both be divided by? Well, both of them could be divided by 6, so that really actually brings my 6 out front. Notice my arrows are going the opposite direction as they did when we distributed, so then I took 6 out of both of them. Well, what's 6x divided by 6? That leaves me with just x. And then what was 30 divided by 6? That leaves me with just 5. There's an addition between them, and I see that these two expressions are equal to each other. So moving on to try that, factor out the GCF from the expression below. So again, I have a variable term and a constant term. So I ignore the variable for a moment, and I think just what about the numbers? What's a common factor here? Well, I made this one pretty easy. 5 can be divided from both of them. So since I see that I'm going to divide by 5, I go ahead and I put 5 parentheses and go ahead and set that up so you don't forget to do anything. Then I think about, well, what's 5x divided by 5? Well, that leaves me with just 1x, which I don't have to put the 1, I just put x. Now be careful, I have subtraction between these two, so I had to carry that over and have subtraction there. And then 75 divided by 5 gives me the value of 15, and I can always check my factoring by doing the distributive property to see, do I get the same thing? Well, if I distribute, 5 times x gives me 5x, 5 times negative 15 gives me a negative 75 or a minus 75, and I would get the same thing, so I know that my factoring is correct. Now this gets a little bit more complicated in situations like what has been throwing some people off on number 11 from that assessment from chapter 1. When I have 2 terms that both involve variables, a general misconception that people have is they say, oh, they both involve m, they're like terms. Well, no, they're not, because the variable value in your first term is m, and the variable value in your second term is mn. Mn is really like a new variable since it's 2 variables connected together. So they're not like terms, but they do have a common factor. I see that I have an m right here, and I have an m right here. I could pull the m out of both of them through division of m. Trying to get that box to go away. So if I divide them both by m, again I put that m out front. Sorry, that box won't disappear. So the m was divided from both of them. Then I think about, what was 7m divided by m? Well, that would be just 7. What would mn divided by m be? And that leaves me with just n. I can think through the distribution and say, would this still be what I want it to be? That would give me 7n, or 7m and then I would get mn, and that would give me exactly what I started with. So my factoring was correct.
Now the last thing I'm going to show today is when we step it up
really hard,
and I can factor out
a coefficient value and a variable. So when I look here, I see 3, 9, and negative 12. Always just kind of take the sign in front of it. As soon as you look at it, I'm not going to say this is minus 12 pH. I'm going to say it's negative 12 pH.
So I have 3, 9, and 12 for my coefficient values.
Hopefully you can think through that, say a common factor of all of those would be 3. So I know that I can divide each of these by 3. So I know that I'm going to go ahead and put a 3 out in front. But there's even more that I can divide out. I then look at my variable values. I have. You've probably already seen this, but I have a P there, a P there, and a P there. So I can factor out all of those, and say really 3 is what's going to get factored out. Then figure out what you have left in your parentheses. Now do not fall in the trap door. 3p divided by 3p does not disappear. Any value divided by itself is 1. Then 9p divided by 3p, so break it up. I do the 9 divided by the 3. I get 3 left over. I do p divided by p, I get 1, and then f just comes along for the ride. Then remember your negative, your minus, however you look at it. 12 divided by 3 gives me 4. The p's cancel out, and I end up with just h. I could check my work, do the distribution all the way through, and it would give me the same exact thing. So I can really distribute or factor with any number of terms. It just keeps getting slightly more difficult. Be careful with that. Watch your details. Always check your work mentally through the distribution. And if you still have any questions about this, please let me know. I'll help you as best as I can. Keep working hard.